Okay, so this is a little tricky to start off with. If we have a look here, sine squared a plus cos squared a equals 1. It says you start from there, use that one to show this one. Now, we know we don't want to fall into the trap of thinking that just because that is identical to 1, that therefore I can just square each term. We know that that is wrong. That would be like saying 3 squared plus 4 squared equals 5 squared, therefore 3 to the 4 plus 4 to the 4 equals 5 to the 4. Totally wrong. That side is 337. This is 625. So we mustn't fall into that trap. But somehow from here we need to get something to do with sine to the power 4 and cos to the power 4. There is a hint in the text, but what we could do is square both sides, but in this way, just as we would square that, that must be identical to 1 squared. That is true, we can definitely say that. So let's just expand out that bracket then. So expanding out gives us this, which is quite promising now, because I've got my sine to the power 4 plus cos to the power 4, and if I now take this to the other side, I can see a double angle formula there. Now, if it helps, I would write out my double angle formula separately, because it's not exactly in the format that I recognise, for sine 2a. And so I need to get a 2 sine a cos a without the squared bit, and deal with that. So if we write 1 minus 4 times, oh, hold on. So 1 minus a half times 4, if I write that instead of 2, sine squared a cos squared a. And now I can have this as 2 sine a cos a all squared. And then I'm getting there. 1 minus a half of sine 2a all squared. And then I just need to pull out that factor of 1/2. So I'm going to have a 2 minus sine squared 2a, and we're there. Okay, we've got our first 5 marks. So we'll have a look at part B now. So deduce that sine 4a plus cos 4a is this. Let's have a look. So my left-hand side here is the same as above, and I need to now write this in an alternative form. So I've got a sine squared 2a, and I want to link that to cos 4a. This is going to be my double angle formula for cos. Again, I would write something on the side over here relating to cos 2a. Start with my basic formula or basic identity. Cos 2a is 1 minus 2 sine squared a. So replacing 4a with, 2a with 4a, think of this as 2 times 2a. So I can then write this as 1 minus 2 sine squared 2a. Okay, now I can replace this. Let's have a look. And I've just rearranged to give me sine squared 2a that I'm going to plug into here. So let's start again, write it out over here for part B. Making it really clear, starting from where we finished in part A, and then just replacing my sine squared 2a with my expression over there. I'm going to take out another factor of 1/2 to get rid of the fraction inside there. So if I've now got 1/4 here. If I'm taking out a factor of 1/2, another factor of 1/2, I need to change that to 4, so that when I multiply it out, I get back to what I should have. Minus, I've taken out that 1/2, so I've got 1 minus cos 4a. This is looking promising. 4 minus 1 is 3, and then I've got a plus, so that will give me what I've been asked. So in part C, I can see I've got 8 times that. So if I just divide everything through by 8, I'll have sine 4 theta plus cos 4 theta to the power 4 theta equals 7/8. So look at that one. Replace the left-hand side with the identity that we found in part B. And note that now if theta is between 0 and pi, I'm going to be looking at 4 theta. So 4 theta between 0 and 4 pi. And then we're just going to rearrange this to give me cos 4 theta equals 1/2 to solve. So inverse cos of 1/2 is 60 degrees or pi over 3. So 4 theta is pi over 3. Because we've done inverse cos, you can subtract that answer from 360 or 2 pi. So I want 2 pi minus pi over 3. So 2 pi is 6 pi over 3. Take away 1 pi over 3 gives me 5 pi over 3. That's my principal solution, is pi over 3. My next solution, 5 pi over 3. To each of those, I can add 2 pi, i.e. 6 pi over 3. So if I add 6 pi over 3 to the first one, I get 7 pi over 3. If I add 6 pi over 3 to 5 pi over 3, I get 11 pi over 3. 4 pi, my range that I want to go up to, is going to be the same as 12 pi over 3, so I don't need to go any further. I've got all my solutions in that range, and then I can finish it off by dividing all of those by 4. So pi over 12, 5 pi over 12, 7 pi over 12, and 11 pi over 12 for all of my answers.